Hello and a very good day. Thank you so much for joining in on this webinar. My name is Abhilash and I am from the AD Solutions or the Active Directory Solutions team here at Manage Engine. And I will be your presenter for today. Now, before we go ahead and jump in, I would like to thank all of you for taking out the time. Thank you so much for being a part of this webinar. Thank you so much for taking the time out amidst your busy schedule. I do understand that the second wave of the COVID virus is rising, and I hope all of you are indoors and home and safe. Now, before we go ahead and jump in, I would like to run a quick audio and video check because I want to make sure that everybody out here today are able to hear me well and are able to see the screen well, right? So if my voice is well and audible without any distortion, without any breakage in the audio, can you give me a confirmation using the Q&A tab, please? Just say yes, just say okay, just say great using the Q&A tab or the chat window so I can confirm that my voice is reaching to you well and clear. Thank you, Mohammed. Thank you, Satyanarayana. Thank you so much for your responses, guys. Looks like everything is okay. Thank you, Mayur. I hope you can see the screen as well. At any point in time during the webinar, if you feel the audio is lagging, and if you feel the screen is getting cut off from your respective computer screens, just let me know, and I'll do my best to get that fixed from my end. And yes, before we begin, I'd also like to tell you that the entire 35 to 40-minute session is going to be recorded, and the recording will be shared on your respective email addresses post the webinar. So if you've got any questions during the course of the webinar, please feel free to use the Q&A tab. Keep your questions coming, and I'd be more than happy to answer them during the course of the webinar. And even if I miss answering your questions, please do not worry. The last 10 to 15 minutes will be a dedicated Q&A session. So I will be answering your questions then as well. And finally, if you have any questions later during the day post the webinar, my email ID is abi@manageengine.com. That's abi@manageengine.com. So if there's anything on your mind that you'd like to ask me, just shoot me an email and I'd be more than happy to help you out any way I can. All right, so let's go ahead and jump in. The topic for today is securing the hybrid transition, extending on-premises Active Directory to AWS or Amazon Web Services, right? Now, why did I choose to speak about this topic today? And why are we talking about Amazon Web Services in particular? Now, the whole reason I chose to speak about extending traditional on-premise environments to public cloud services like Amazon Web Services is because there is a shift in the IT landscape. Right? More and more companies are looking towards the public cloud infrastructures like Azure, like AWS, like Google Cloud as a vital part of their traditional on-premises infrastructures. Most of you who've joined here today, I'm pretty sure you already have an on-premises Active Directory infrastructure and you are thinking about adopting Amazon Web Services, or you already have Amazon Web Services and you might be thinking how you can perfect the security of AWS. Right? So the pandemic has forced people, has forced employees to go remote. And because of this, it has forced organizations to preserve cash and optimize IT maintenance costs and IT support costs. It has forced organizations to support and secure a remote workforce by giving them the applications they need, by giving them the resources and the tools they need so the remote employees can perform their job without any obstruction. And last but not the least, the shift to the remote work lifestyle has forced organizations to look into scalable methods of computation. Right now, because we've all gone remote, the resource usage may go up, may go down, and we need a service or an infrastructure that can help you easily scale your storage or scale your resource usage up or down based on your computational levels. Right? So the pandemic has forced organizations to preserve money, point A, and point B is to support and secure a remote workforce by giving them rapid access to the applications, the tools they need, and also have a scalable infrastructure in place, because since we're remote, there's no saying that usage may go up, usage may go down, and all sizes of businesses, right? The small, medium businesses, the enterprises, the larger businesses are all looking towards adopting public cloud services. Right? Now, the reason I say public cloud services is because businesses want to adopt something that is not much on the cost end, that is not cost effective, that is not too much on the cost end, but also benefits their organization in one way or another. Right? So if you take a look at the graph in front of you, you will notice that AWS, Azure, and Google Cloud are the top three adopted public cloud services. Right? Smaller businesses, they choose to adopt public cloud services because generally smaller businesses, they do not have the budget and they cannot afford the capital cost that is involved to build an on-premises environment or an on-premises IT infrastructure from scratch. So choosing a public cloud service, offloading their needs to a public cloud service like AWS or Azure becomes a viable option. Medium, large size businesses, enterprises, all of them are also adopting cloud services. Now that we've all gone remote, companies cannot afford to keep resources in-house anymore. So they've started looking towards the cloud. But the important thing to note here is that although medium and large size businesses, they are adopting public cloud services, they haven't completely shifted to the public cloud service either. Right. So what I'm trying to say here is most organizations, they have either purely shifted to a public cloud service, and many organizations around the world, I'm pretty sure you as well, are adopting public cloud services alongside traditional on-premises infrastructure. So they are trying to strike a balance between on-premise infrastructures and cloud infrastructure so they can leverage the best of both the worlds. Right? So it is noted that from a survey around organizations that use cloud services around the world, public cloud services are used at a rate of 96%. That's right. In this survey that was conducted by Flexera, 96% of organizations use public cloud service in one form or another. Right? So as you can see from the graph, Amazon Web Services remains the top adopted cloud service. Now it's safe to say that Azure is quickly closing in with AWS, but AWS remains the most adopted cloud service in 2020 and in 2021 as well. Right? So that's the whole concept of this webinar. The reason we thought of making this webinar series of transitioning on-premise to the cloud is because I'm pretty sure most of you out here may be thinking about adopting a cloud or already have a cloud service. So we thought, why not conduct a webinar series that goes through the top cloud services, and why not conduct it in such a way where we can show how we can secure on-premise environments, especially when they are connected to the cloud. Right? So today's focus, as the title says, is AWS. But if Azure is more of your concern, we conducted a webinar on Azure last month. Basically, it tells you everything you need to know to secure your Azure infrastructure. So if you're thinking of adopting Azure alongside AD, this webinar will tell you everything you need to do to secure your AD and your Azure configuration, right? So I'm quickly gonna copy the title of that and leave it in the chat window right here. So for those of you who are interested in Azure more than AWS, do check this out. This will tell you everything you need to know to secure your Azure when you deploy it alongside Active Directory. But for now, let's head back to AWS and see what we have in store. Right? So everything looks good, right? Enterprises are realizing the benefits of the cloud, and we can actually see a future of IT that is dependent on cloud and cloud alone, right? But there's one thing to note here, and that is increased cloud adoption or increased cloud usage does not mean all problems are solved. Enterprises are adopting cloud services, that is good. But does cloud actually give you what you need? Does cloud include that? Does cloud bring in new elements of risk inside your already secure and stable on-premises infrastructure? Is it possible a cloud service adoption in your environment is opening doors or increasing the attack surface, right? So that's what we're going to look into today. And yes, like I said, AWS is a go-to choice for most businesses. You can see the reasons for it right in front of your screen right about now. And like I said, security is still the biggest problem when it comes to adopting a public cloud service. right? So if you take a look at the graph in front of you, you will notice that whether the cloud service happens to be a beginner, whether it happens to be an intermediate or an advanced user, security happens to be the biggest problem whenever organizations adopt cloud, right? Because cloud, although they are extremely powerful, although they are much, much better than your on-premises infrastructures, cloud services, they are introducing a few elements of risk inside your existing AD environment. If an attacker compromises a cloud environment, he or she can do anything they want in the cloud and eventually also pivot and move to your on-premises infrastructures, right? So the cloud service, like I said, are much, much better than your on-premises services, right? They have better security, they have better infrastructures and data centers because these cloud vendors like Microsoft or Amazon, they spend a lot of money in perfecting the cloud service, in securing it, and things like that. So how do attacks in the cloud happen? Because from what it seems like, cloud services are much more secure than on-premise services, right? Because when it comes to an on-premise infrastructure, you alone are responsible for the security of the on-premise infrastructure. But when it comes to a cloud service like Amazon Web Service or Azure, the vendor is responsible for security of the data centers and the infrastructure in the cloud, right? So why are cloud services being attacked? Why is cloud security still a problem? The reason for that is because when you look at the cloud security model, you will notice that the vendor who's providing the cloud service is responsible for the infrastructure part of it, right? But the configuration part of your public cloud service still depends on the end user, the customer, yourself, right? So the customer plays a major role in securing the cloud. And the biggest reason for security breaches in the cloud is due to client-side errors or client-side misconfigurations that attackers will search for and then try and compromise your cloud environment and eventually move to your on-premises environment. Right? So the focus of today's webinar will not be on vulnerabilities in the cloud. Now, AWS, Azure, they are actually pretty secure services, but the focus on today's webinar will be different misconfigurations that you can do from a client's perspective, from a customer's perspective, and how these misconfigurations could lead to the compromise of your cloud infrastructure. Right? So the first example we have is connecting AWS to Active Directory. So when you typically deploy AWS in your environment, the first thing that you would naturally do is basically synchronize your Active Directory users to AWS, right? And AWS offers a service called the AD connector service. It kind of acts like a proxy service that allows you to use your on-premises users' credentials to sign into AWS and perform duties or perform jobs in AWS, right? So I do not wish to complicate this further. Just know that with AD connector, your users' AD credentials or Active Directory or on-premise credentials can be used in AWS, right? So here's the diagram that you see right here. When a user enters the credentials in the AWS sign-in page, the AD connector service kicks in. The AD connector checks with the Active Directory domain controller if the user's credentials are correct. And if they are, then AD connector will let the user log on to AWS, but at the same time, assigning the roles and the permission that the user must have in AWS, right? So AD connector is a beautiful tool provided by AWS that will allow you to basically synchronize your AD users to the cloud. And this way your users can use same AD credentials to log into AWS as well. And the important thing to note here is that AD Connect also allows your users to use the same Active Directory policies. Policies such as password policies, account lockout policies will be the same for users in the cloud as well, because essentially they are logging in with the same password, right? So all your Active Directory password policies will now be responsible not just for Active Directory security, but for AWS security as well, because your users, they're using the same credentials. And let me show you how this can be broken into. If I open up my virtual machine right here, and you can see this is my PowerShell session, right? And here's what I'm going to do. I will run a command called import module dot slash domain password spray. ps1, right? The module has been imported. This is just a simple PS script or a PowerShell script. And here's what I'm going to do. I'm going to run a command called invoke domain password spray, and I will give in a password which happens to be, let's just say password at 123, right? A pretty simple password, pretty commonly used password, but still widely prevalent in most organizations, right? So once I hit enter, here's what's going to happen. What the script is going to do, what this PowerShell script is going to do, is it is going to check for all your Active Directory policies, your fine-grained policies, your password policies, and then it will spray the password at 123 on all the users on your domain, right? So once I scroll down and I say yes, basically I'm confirming the attack, and you can see within a few seconds, I have users and their plain text password. Now, these users could be inactive users, name basically users who are enabled but haven't been logged onto in a long time. These could be users with with weak passwords like password at 123. The reason could be anything, but my point here is I now have access to a user and I have access to the user's password, and I can use the same credentials to log into AWS as well, because we've connected AWS and AD with AD Connector, a tool that's offered by AWS, right? So that's my point here. Active Directory's password policies, they are pretty weak, right? So if I head into my group policies right here, this will be the password policy of my domain, right? And do you see these 6 settings? These 6 settings are responsible for the password creation and password security in your AD domain. Now, I do not wish to complicate this further, but just know that these 6 settings, they have been around for the last decade. For probably more than 20 years now, Active Directory hasn't updated these settings, and that's why users can get away with passwords like password at 123, and that is why security attacks happen in Active Directory, right? Similarly, your account lockout policies, these can be broken into as well because they do have a few security limitations. For example, do you see the account lockout threshold? This basically is used to lock out an account if password is entered wrong many a times, right? But this account lockout threshold, which is set to 10, does not apply to your administrator user. That's right, your most powerful user in Active Directory, basically your administrator user, does not have an account lockout policy, right? So what's the problem with it? What if a user does not have an account lockout policy? Means the account will never ever get locked out. Means the admin account in Active Directory becomes a prime target for brute force and password brute force attacks, right? So that's my point here. Policies are weak, they are old, they can be broken into, and that's how your AWS environment can be compromised as well. And you can prevent this by monitoring logons to your Active Directory environment. Then how do you monitor logons to your Active Directory environment? You'll have to head into something called audit policies, and you've got to enable the required audit policies, right? Audit policies basically record certain security events on your domain, and these are crucial for you to ensure security, right? So let's just give this a second. So looks like this is going to take a while, but once you enable audit policies and once you enable auditing for logons in Active Directory, what happens is whenever a user logs on to an Active Directory domain controller, the logons will be recorded, right? And you can view all of those logons from your Active Directory event viewer, right? So here you go. These are the logon events, these are the log off events, and it's important that you monitor these events to detect any security attacks via logon attempts in your Active Directory domain, right? So it's crucial that you do that, and that can be done with advanced audit policies. And once you're in advanced audit policies, enable logon auditing for all your Active Directory users. Use the event viewer to detect logons, right? But the problem is the event viewer is actually a pretty messy tool. You can see the number of events here is around 140,000, and it's extremely difficult for you to walk through all of these events and understand what's happening here, spot anything suspicious or malicious. And that's where we simplify things for you, because in Log 360, we offer something called logon activity monitoring. So you get to know which user is logging on from where, right? Which domain controller is the user logging on to? What was the logon time? Was the logon a success or a failure? You can search through these reports as well, and you can set up alerts as well, right? So you can monitor logon activities across your Active Directory domain controllers, across your member servers, across your workstations. And at any time, if you find logon failures, unusual logon failures occurring in a little span of time, as you can see right here, just a minute or a few seconds, it could be an automated password attack. And you can set up alerts where the authorized users, like your admin, will receive an email or an SMS saying, hey, there has been an invalid logon attempt on your Active Directory domain. Please check it out, right? So these reports right here will help you detect logons, monitor logons across your member servers, your workstations, your domain controllers, and detect any invalid logons, and also potentially alert you on them, right? So unfortunately, because the policies are old, the only way you can prevent such attacks is by monitoring logons, and we can help you do that, right? Not just the password spree attack, there are many other ways Active Directory passwords can be compromised. For example, I could simply launch my task manager on an endpoint machine connected to the Active Directory domain. It could even be a guest machine. And I can head into details, open up a service called the LSASS service, and I could hit right click, create dump file. And with the dump file, I can take the dump file home, open up Mimikatz, and extract credentials from it. Right? The LSA also stands for the Local Security Authority, is the local memory of the server, using which I can take a dump file, a memory dump, and using Mimikatz in my own system, I can extract credentials from it. Right? This is just another way Active Directory passwords can be compromised, and you can only prevent such attacks by monitoring logon activities on your domain. And not just logon activities, we also have something else that is really important, and that is called PowerShell auditing, right? So the next time your users are trying to run scripts that could be attack scripts, next time your users are trying to invoke certain PowerShell commands, these two reports right here will detect such activities. You get to know which user ran the command, you get to know what the command is, and of course, you can set up alerts as well. Coming into script block logging, you can log the entire data. You can read through the code blocks in the script to truly understand what the script is, what it does, and why an end user is executing it, which is also useful for you to detect any password attack attempts that are automated, which is often via PowerShell scripts, right? So that's the first use case right here. AD to AWS connection, that's good. But AWS uses AD's password policies, which can be broken into, and you can prevent such attacks by monitoring logons and also monitoring PowerShell activities, thereby securing not just your AD infrastructure, but also your AWS infrastructure where users are logging on to using the same passwords and the same usernames even. Right? The second important thing I wanted to talk about is identity and access management in AWS. Right? So for those of you who've already been using AWS, you probably have already seen this. If I head into my AWS console, search for IAM, this is where you create your users. This is where you give certain privileges to your users. And this is where everything relating to IAM happens, right? So you could create users. For example, I could add a user. I could call the user ABI, provide access to the user. I could give the user, add the user to a group, right? Now, groups can have roles attached to them. Groups can have policies with certain permissions attached to them, or you could attach the policy directly to another user. For example, if I want my user to be an admin, I could directly assign the admin policy to my user. And once the user is created, the user will be an administrator, right? So identity and access management in AWS is actually a mix and match of security because you need to create users. You can create roles, assign them to the users. You can create roles, assign them to groups, and add the users to the groups. Your policies can also be assigned to your groups and your roles as well, right? So you need to ensure that only the right user has the right role or has the right policy or has the right group membership to perform activities inside the AWS console, right? So how can this go wrong? Let me show you a simple example right. So there is a policy called the attached user policy. Now, if a user by mistake is added to a group that has the attached user policy, or if a user is granted a role that has the attached user policy, or if a user is directly assigned the attached user policy, what happens is the user has the right to attach any policy to himself, right? Now, if an attacker compromises this user account, here's what happens. The attacker will log on as that user and then basically assign himself any policy that he or she wants. For example, this is my user, and an attacker has compromised this user, and an attacker can simply attach existing policies like admin policies to that user, because this is the function of the IAM attach user policy, right? This is just a simple example of how a single misassigned policy to a user account can give an attacker administrative access, right? If a user has attached user policy, an attacker can basically create a new policy with higher privileges and assign that compromised user account the policy. The attacker could assign specific roles like manage group memberships or manage roles in AWS to that user, because again, this is one policy that acts like a wildcard that gives the user everything, any modification options in AWS, right? So that's why I say monitoring everything that's happening with respect to IAM in AWS is crucial. The next time your users' passwords are not updated, the next time your users are added to groups, the next time a role is assigned to your users, the next time specific policies like the attached user policies are assigned to your users, do monitor them, do note them, and if anything is unauthorized, immediately disable the user, right? So the third example I have right here is your Amazon S3 buckets. Now, your S3 buckets are typically your storage accounts in AWS, right? It's important to know that your S3 buckets can be misconfigured in many, many ways, right? Let me show you a simple example right here. If I minimize this, open up my browser, head into AWS, I'm going to search for S3, right? So this is my storage in AWS, right? I have a bunch of buckets right here. Let me quickly open up a bucket, head into permissions, right? And do you see the first mistake right now? It says objects can be public because public access has been turned off. This means any user with access to the URL of this bucket can view anything that is stored in the bucket, right? Similarly, if a bucket policy happens to be weak, right? For example, let me quickly show you an example right here. Do you see this? This is a bucket policy that will allow any user to enumerate or to basically retrieve whatever is stored in a bucket. This is not really good, right? Because a bucket policy must be secure. Only authorized users must be allowed to access things in a bucket and not all users or anonymous users, right? Similarly, the access control lists on the AWS bucket or the S3 bucket can be misconfigured. A random user may have write access on the bucket or read access on the bucket. A random group of which many users are members of may have write or read access on the bucket, right? This is not good. So there are many ways buckets can be misconfigured. Public access can be enabled. Policies can be misconfigured. Access control lists or ACLs on the bucket can be misconfigured. And all of these are something you absolutely need to look into to ensure bucket security, right? Let me show you something interesting right here. Do you see this tool right here called S3 Scanner? Now, there are many tools like this on GitHub that basically find open buckets and dump their content. So there are tools out there that can be leveraged right now by attackers to dump everything that is in your misconfigured bucket, right? So ensure that only authorized buckets are public. Ensure you monitor the access control entries on the bucket. Ensure that the policies are strong on the bucket, because permissions can be granted in two ways: via policies and via access control lists on buckets, right? So not just your third-party tools like the S3 scanner tool that I just showed you. Attackers can also leverage the AWS command line, right? The AWS command line that comes built in with AWS. Attackers can also leverage this to extract things from your S3 buckets, right? So there are many ways buckets can be misconfigured. Buckets may allow for full anonymous access. There may be users with permissions to upload or download data from buckets. There may be users who can retrieve and enumerate objects in a bucket, right? Buckets store everything. They store your files, they store your folders, they store your application configuration, they store your messaging queues details, everything buckets handle, and it's important that you monitor buckets because they're responsible for everything, your files and folders to the services in your AWS infrastructure, right? So how can you monitor accesses on an S3 bucket? This is how you do it. Let me quickly show you an example. If I head into AWS, this is my bucket, right? And if I head into properties, scroll down, and you will find something called server access logging that is enabled on the bucket, right? So whenever server access logging is enabled, what happens is anyone who's accessing the bucket, anyone who's changing permissions or modifying things inside the bucket, all those details will be pushed to another target bucket, right? So any accesses to the bucket, basically server access logging logs all of those activities and it pushes them to a target bucket that you can specify, right? So once this is enabled on a bucket, the next time a user accesses a bucket, the events will be in the target bucket that look something like this, right? So as you can see from the diagram right here, there are a few source AWS buckets with server access auditing enabled. And once server access logging, I'm so sorry, is enabled, they are pushed to the target bucket that hosts the log files using which you can detect any unauthorized access on your AWS bucket. But the logs here inside the bucket, they look very, very difficult to understand, right? This is how the logs look like. And this is what the information translates to. A new object test file, basically an image, was put into the bucket on so-and-so time from this IP address. This is how the logs look like, right? So although it is logged, the information is not really readable. Like you can't look at it in one glance and understand what's happened on the bucket. You have to read through all of this to truly understand what's happened on the bucket, which user accessed it, what was added to the bucket, or what was deleted from the bucket, right? Amazon tries to simplify this for you because it offers a service called Athena, right? Using AWS Athena, you can run certain SQL queries. You can run queries to extract data from your S3 buckets that store the logs like this. So you can construct queries to find out specific actions on the bucket. But then again, it's time consuming. It's not that easy. And you have to pay extra to use AWS Athena. Right? The fourth thing I want to talk about here is CloudTrail. Since we're on the concept of logging accesses, let's discuss CloudTrail as well. So CloudTrail in AWS basically lets you know which user can access what in AWS, right? So let me show you an example. If I minimize this, open up my browser, head into something called CloudTrail, right? So this is my CloudTrail, and this is where you can log activities on every object in AWS, right? So there are multiple regions, as you can see right here. You can log activities on all regions. So all you got to do is click on create trial. So I'm just going to call this test event, right? I'm going to enable this. You could choose to create a new bucket, or you could choose to use an existing bucket. So what happens is whenever CloudTrail is enabled, every activity on the objects in your AWS environment, like your users, your EC2 instances, etc., will be pushed to a bucket, and you can review the logs in the bucket to detect anything suspicious or malicious that's happening. So I'm going to create a new bucket, and I'm going to basically say test events right here. And once I hit next, you can specify what you want to be recorded, what events you'd like to be monitored, right? So when I say management operations, it's basically any user who's given an IAM policy, any user who's logging on to AWS, any user who's given a new role or a new group membership, or an EC2 instance that was changed, or a relational database that was modified. So basically, this is how CloudTrail events look like, right? So it is basically in JSON format. And if you look deep into it, you will realize that this is an event that says instances or EC2 instances, basically your virtual machines in AWS, they have been started in this region, and this is the source address. Right? So configuring CloudTrail is very important. I would encourage you to configure it right away because this will enable you to log activities that are happening in AWS, right? Not just user or EC2 or relational databases based activities, but also you can monitor data modifications inside certain objects. For example, here you see data event happens to be an S3 bucket. So if a file is added to a bucket or if a file is deleted to a bucket, you can monitor those activities. Similarly, you can monitor AWS Lambda and DynaDB services as well. Right? So once you hit next, a CloudTrail will be configured and everything will be pushed to the bucket where you specified the target, right? So I'm going to say S3 right here, and I've already have a CloudTrail configured. So let me quickly show that to you. Here you go. These are my CloudTrail logs. So if I click on it and if I look into it, I will get to see all the logs that have been recorded for a single region or for all the regions, basically global regions in my AWS environment. Right? So the log files, well, they look something like this. So this is what logs files look like inside your target S3 bucket where you've recorded all the logs. Right? So I would encourage you to configure CloudTrail as soon as possible. And there is something else in AWS that you can leverage for security purposes, and that is basically called event history, right? So if I head into event history, this will show you every activity that has occurred in the last 90 days, right? So let's say I want to look for an event that basically tells me if someone has logged on to a console, right? So these are all the logons that have occurred in the last 90 days, right? But remember, all of these logs, all of these events that you see right here, they're only for 90 days. And if you want to enable logging for more time, the only way to do that is to configure a CloudTrail in AWS, right? So CloudTrail is great. It allows you to audit all your AWS resources for changes, for modifications, for permission changes. You can store all those logs in an S3 bucket and you can view what's happening, but you need to monitor your CloudTrail for unauthorized changes as well, right? Now, what do I mean by unauthorized changes on a CloudTrail? Users or attackers in your environment may delete your CloudTrail instance, or they may actually stop logging on your CloudTrail instance, right? These are all illicit activities that happen when an attacker is trying to hide his or her tracks in your AWS environment, and these activities must be noted, right? So here's what, these are the final takeaways from this fourth point. Enable CloudTrail, ensure that only authorized users have access to your CloudTrail. You can do that with your IAM feature in AWS. So when you head into IAM and let's say users, let's say I want to create a new user. I'm just going to call the user Abi, and you can assign policies to that user, which can then be used to manage CloudTrail, right? So I can just say CloudTrail right here. And these are the policies that allow a user to access a CloudTrail fully or just read the events inside the CloudTrail. So ensure that only authorized users have access to the CloudTrail. Monitor events such as CloudTrail deleted or logging randomly stopped in CloudTrail. And most importantly, do configure CloudTrail if you haven't configured it already, right? So attackers using not just a UI, but also using AWS command line can basically delete the buckets in which CloudTrail logs are being audited or are being stored, can basically stop the logging of events in CloudTrail and can do a lot more, right? So not just using the UI, where attackers head into the UI, head into CloudTrail and make changes in it, like stopping to log or deleting the log. Attackers can also use the AWS command line, right? So not just this way. I apologize, my internet is a little slow, but here we go, right? So not just delete or stop logging using the UI, AWS command line can be used as well. And that's something you need to look into to monitor illicit activities on CloudTrail, right? And this will happen only if permissions on your CloudTrail are misconfigured. And I would encourage you to secure that first. The fifth point right here is open network connections. Now, you may have EC2 instances or virtual machines in AWS. You may have VPCs in AWS. VPCs, consider them as individual networks inside your AWS that allow you to subset your devices and use them as separate networks. For example, if you have different teams, you could create different VPCs and create a separate network for those teams alone, so you can manage them separately and more efficiently, right? So another top reason why AWS is breached is because network connections, well, they are not that secure, right? So if I head into AWS again, open up the console, you will notice something called security groups right here. Now, security groups are used for EC2 or your virtual machines. Security groups are also used for VPCs. Like I said, these are individual networks that you can split based on teams, based on devices for your own comfort. And security groups basically determine the traffic to your instances, right? So I have a security group right here. If I just open it up, you see this inbound rules. This basically tells you who can access this EC2 instance, this virtual machine, right? This the outbound rules basically tell you what the EC2 machine can access on the internet, right? So you need to specify strict inbound rules and strict outbound rules, right? Here are a few misconfigurations on EC2 instances that can put your entire AWS configuration at risk. Do you see this? Source 0.0.0 as an inbound rule. This basically means anyone on the internet, anyone in the public can connect to your EC2 instance, or potentially can even connect to your, like I said, your your VPCs in AWS, virtual private connections, in other words, right? So either ways, this is a security risk. Security groups act as a firewall, setting inbound and outbound rules. So do ensure that your inbound and outbound rules are good, right? Similarly, when an RDP rule is set like this, anyone can log in to that EC2 instance, right? So here's what I would encourage you to do. Whenever you set up an EC2 instance, whenever you set up a relational database, whenever you set up a virtual private connection, basically a subset of networks in AWS, ensure the security groups have strict inbound rules and strict outbound rules, right? Do not set an inbound rule to 0.0.0 because that basically says anyone can access that instance, that EC2 machine or that virtual private connection, right? So these are some network connections that can put your network at risk. And another thing I would say is, let's say you as an admin have to deploy patches to various EC2 instances or virtual machines in your network. One way to do it is to remote into them, but I would encourage you to not do that. Use tools like uh, Chef, for example, in AWS, using which you can automate patch deployment to EC2 instances in your network, right? And if you have to enable remote access to your EC2 instances or your virtual machines, I would encourage you to use something called Bastion Host. Now, Bastion Host happens to be an intermediary host, right? So every time your users need to remote into a virtual machine in AWS, they can do that via the Bastion host or the intermediary host, right? And not directly remote into that virtual machine. Right? So secure your EC2 instances, secure the permissions, secure the network connections on your EC2, on your VPCs in your AWS environment by setting strict inbound and outbound traffic rules on your security groups. That's my next point. We're almost reaching to the end of the webinar. We have one more point here, that is exposed access keys and root user keys, right? For Active Directory, it's all about passwords. You need to secure passwords. You need to secure your users, right? But when it comes to AWS, there are two things you need to look into. If I open up my browser and you can see I'm logged in as Bharat because this is the only credential I have. If I head into my security credentials, right? You can see that Bharat's password has been changed 6 days ago. This is a good password change frequency. I would encourage you that you change passwords for all your AWS accounts at regular intervals, right? So there are two things in AWS: passwords to log into the console and access keys for API access, for CLI access, or for SDK access in AWS. Change your passwords regularly, change your access keys as well regularly. If your users have forgotten their access keys, do not share them the old access key, but create a new one and share it to them, right? Another important thing I want to talk about here is for your root user. Whenever you set up your AWS, you have an AWS root user, do disable the key for the root user or even delete the key for that matter for security. The mistake that I've seen in most AWS infrastructures is the keys to the root user are not disabled, and that is a security risk. And the last thing I would encourage you to do is enforce multi-factor authentication. Don't just trust your access keys or your passwords, enforce multi-factor authentication, if not for all your users, at least your privileged and your admin users in AWS. Right? So there are many ways access keys and root user keys can be broken into. Often developers leave access keys and root user keys in the application source code, in configuration files. And there have been, believe me when I say this, S3 bucket ransomware attacks because the developer forgot the access key to an S3 bucket or to an AWS instance in a repository that is in GitHub. Right? So these are things that you must avoid. Rotate your access keys, rotate your root user keys, ensure that you don't leave access keys in your config files, in your code, or even when you upload files to GitHub, right? The last use case for today is encrypting what needs to be encrypted, right? This is a mistake that I see in most organizations. For example, let me minimize this, open up my AWS console, and let me quickly open up S3 bucket, right? So this is my S3 bucket, and let me show you something right here. Let me open up a bucket, head into something called properties, scroll down. Do you see this called encryption? It's disabled on the bucket, right? So when encryption is disabled on a bucket, the objects in the bucket, they are not encrypted, which means if a bucket, let's say, due to a configuration error or due to a mistake is set to public, attacker can access all the objects in the bucket because they are not encrypted, right? So I would encourage you to enable encryption on the buckets, right? Bucket versioning is one another example where different versions of a bucket are created whenever there are changes made to the bucket. So if there is something irreversible that's happened in your organization, let's say an attacker has logged in and deleted a bunch of files from the bucket, using bucket versioning, you can go back to the previous version and restore what you initially had. Right? So this is kind of a restore point for your buckets. You can also enable more security features like MFA delete. Whenever a bucket is deleted, whenever an object in a bucket is deleted, you can enable multi-factor authentication just to ensure security. These are a few encryption techniques that remain unused and eventually jeopardize the security of your AWS environment. Right? Not just buckets. If I head into something called EC2, these are the virtual machines in AWS. And if I head into volumes, right? Volumes basically determine the hard disk or the disk usage or the storage space in the EC2 instances. And most often I've seen this, that volumes are created without encryptions, right? This is another security risk. You must encrypt the storage in your EC2 instances because that could lead to a security incident, right? More ways things can be broken into if they are not encrypted. Right? For example, when you have relational database services like RDS instances created without encryption, that is a security threat. Right? Your CloudTrail logs that we just spoke about, they must, the log file validation on those must be enabled as well. Right? So when you enable log file validation, what happens is whenever a user decides to tamper on an event stored inside a CloudTrail log, right? So let me open up CloudTrail. I'm sorry. Let me open up my S3 bucket so I can show you a CloudTrail log. So S3 buckets, and you see the buckets right here, and you see all the CloudTrail logs. Whenever an attacker decides to tamper a CloudTrail log, delete it or modify it, they will not be able to do it because log file validation has been enabled. Right? Similarly, you can enable KMS encryption using a key, called the AWS KMS key for your log files in CloudTrail. Right? This is the seventh misconfiguration that happens, not encrypting what needs to be encrypted. Right? So there's a lot we looked into today. We looked into IAM, we looked into S3 buckets, we looked into CloudTrail, we looked into security group rules, we looked into encryption, a lot and a lot and a lot more. And the important thing to realize here is that these are not mistakes. These are not vulnerabilities. This is not something that's wrong with your AWS infrastructure. This is something that happens on the customer end, all the client end, right? These are misconfigurations. These are mistakes in your AWS infrastructure, right? So if your AWS infrastructure is secure, if the permissions are proper, if the network is not misconfigured, chances are the attacker will jump onto another AWS instance because they are generally looking out for quick and easy ways to compromise your AWS environment, right? So Log 360 can help you monitor everything in AWS. IAM activity, any resource modifications, any unauthorized changes on configurations. It can help you alert authorized users. It can help you filter, search, and comb through all the events that are in the CloudTrail in AWS, right? So this is what it looks like. If I open up Cloud Security Plus, a component of Log 360, here you have AWS logging, right? If your user is granted a role, if your user is added to a group, if there's any IAM-based changes, and not just IAM-based changes, your other resources, like security group configuration changes, or S3 buckets that were modified, or files inside the S3 buckets that were modified, or any EC2 instances that could have been modified, right? Or anything relating to AWS configurations. So all of these changes will be recorded, and you can search for all such changes using the reports right here, right? I apologize, I'm unable to show you the reports because my internet is a little bit slow, but all of these reports are much better than your CloudTrail reports. They help you to search through what's happening in AWS, and they also help you to alert on certain activities that are happening in AWS, right? So if I head into reports right here, and let me quickly try and see if I can generate anything, right? So you can select the users that you want. You can monitor respective IAM activities. And yes, so once the report is generated, you can search through the report. You can see what's happening. You can set up alerts as well. So the next time there's a change in AWS, like a user assigned a policy or an S3 bucket change or an EC2 instance change or a virtual private connection change, you will immediately receive an alert via email and via SMS. So nothing ever goes unnoticed, right? So what the solution essentially does is it takes all your CloudTrail events and it segregates them in the form of reports that are easy to read. So these are essentially all your CloudTrail events, right? And then it allows you to filter the report, search through what's happening in the report, and also allows you to alert on anything sensitive, suspicious, or malicious in the report, right? Not just AWS, we support Azure, and we support Google Public Cloud and Salesforce as well, right? So do let us know which is your concern. If on-premise security is something of your concern, let me know. If you want more insight into Azure or AWS for that matter, if you want more insight into other cloud services like Google Cloud, do put it in the chat window or the Q&A tab, and I'll get that set up for you. And yes, that is about it for today. Thank you so much for your time. Thank you so much for your attention. And before I wrap up with this webinar, uh, you will now find a quick question on your screen in the next 1 second. Here you go. So if you can help me out with the answers, that would be really helpful. This is just for our internal team. Thank you for your responses. Thank you so much. Just a few seconds of your time. Thank you so much for your responses, guys. I would love to hear what you thought. Uh, I hope you found the session informative. I hope we were able to look into a new perspective on AWS security. If there's anything you want me to do, if there's a new topic that you'd like for me to cover, please do let me know, and I'd be more than happy to do that for you. Thank you for your responses. Much appreciated. Thank you. Thank you so much for your responses, guys. Thank you. Thank you for your responses. Much appreciated. For those of you who've been asking me for the slide deck, please do not worry. I will ensure that the slide deck is sent to your respective email addresses along with the link to the YouTube recording as well. Brilliant, guys. Thank you for your time. Thank you for your attention. I hope you found the session informative. And stay home, stay safe. And if you have any questions, you've got my email ID right in front of you. You can just drop it to me anytime. And yes, thank you. I hope you had a great time. And I hope to see you in the upcoming sessions. Stay home, stay safe. Bye bye.